Natural disasters. More than 700 have been registered worldwide since 2010, affecting more than 450 million people with reported damages of 20 billion to 100 billion per year. Your colleagues are working with satellites in space and developing algorithms to better detect a disaster before it hits, reducing financial impact, saving lives. Hello, I'm Monica Rosenfeld from the Institute, and you're watching Tech News on IEEE TV. Sinkholes are often large enough to swallow a house whole or a street full of cars. In May alone, sinkholes were reported in more than 20 states in the U.S. There's never been a successful technology for sinkhole detection until now. With the guidance of IEEE fellow Professor Scott Acton, 2 graduate students from the University of Virginia have developed an algorithm that analyzes data from existing Earth-sensing satellites to calculate changes in ground level. Their work helps indicate potential sinkhole locations.
With a combination of signal processing technology, algorithms, and imaging technology from satellites, which is all good IEEE technology, we've been able to locate sinkholes, and we believe maybe in an automated sense for the first time.
The project was financed by a $870,000 grant from the U.S. Department of Transportation's Research and Innovative Technology Administration. The funds cover a study of a 40 by 40 kilometer area on Interstate 81 in Virginia that was chosen for its diverse geological conditions.
We create a template, a particular curve that evolves in time, and we go around in the data and look if any region has that particular behavior. If it has that behavior, we mark it as interesting. And then the most risky regions are identified, and then we send a crew out to check them.
Acton says his team is planning a new proposal to continue the development of their work and implement it on a larger transportation network, reaching several states. Learn more about Professor Acton's work at the Institute. Earthquakes are one of the most difficult disasters to forecast because of their seemingly random nature. In the first 6 months of this year, 80 quakes with a magnitude of 6 or greater were reported around the world, but only after the event. Now, thanks to advances in remote sensing technology and the work of IEEE members in China, information from sensors deployed on buoys, weather stations, and satellites can give better clues to recognize when and where an earthquake might strike. Using data from the Global Earth Observation System of Systems, otherwise known as GEOS, WU's team looks for anomalies like changes in ground stress, temperature, moisture, and electromagnetic radiation. The researchers tested their data on the Wenchun earthquake, a magnitude 8.0 that struck China in May 2008. The group will soon develop a software system that will be available for free to members of Group on Earth Observation, a partnership of 90 countries and 67 international organizations. Their paper was published in the October 2012 proceedings of the IEEE Special Edition on Remote Sensing of Natural Disasters. Learn more about earthquake prediction work at the Institute online. Natural disasters cannot be prevented, but creative application of technology can help reduce its damage. A series of satellites on board NASA's Terra spacecraft that monitors Earth's nature, known as ASTER, is one example. ASTER provides high-resolution images of Earth in 14 bands of the electromagnetic spectrum. The images identify changes in the land, atmosphere, climate, and oceans. It can monitor glaciers and volcanic activity and track floods, hurricanes, and earthquakes.
One of the big events we were greatly involved in is the Tohoku Fukushima earthquake and tsunami that happened in March 2011 in northern Japan. This was particularly important because it happened to our colleagues, the Japanese, who jointly operate the mission. So ASTER was tasked, that is, we created a schedule to acquire all the images that we possibly could every time ASTER was in sight of the east coast of Japan for the northern half of Japan to assess the damage.
ASTER is a joint project of Japan's Ministry of Economy, Trade and Industry and NASA. The project was put into effect 14 years ago with the purpose of tracking changes that can help better detect and monitor natural disasters.
Most disasters, they just happen unpredictably. One of the things we can do extremely well is look at heat using thermal infrared channels. So we can look at changes in the behavior of volcanoes that potentially could indicate an impending eruption.
For more on ASTER and how its data is used to monitor Earth, visit the Institute online. Technology to detect and warn of natural disasters might appear rather new, but people have created warning systems for more than 175 years. These systems incorporated the telegraph and the electric seismograph, as well as an electrical warning system for tornado-prone areas, which never got built. The reason? The word tornado was banned by the U.S. Weather Bureau from 1885 to 1938, fearing it would panic people and discourage them from settling in tornado-prone areas. Take a look at the story from the IEEE History Center at the Institute. Also at the Institute this month, you'll find out about IEEE's Open Access Mega Journal, comprised with research covering all of IEEE fields of interest, a list of conferences focused on natural disaster mitigation, and a closer look at IEEE member achievements and part-time passions. Thanks for watching. I'm Monica Rosenfeld, and this is Tech News on IEEE TV.